Good morning. It is 9 o'clock here in California. I am Francis Savignan, the founder and CEO of EPARTRADE. With me is Judy Kin, the co-founder of EPARTRADE. Good morning, Judy. How are you?
Good morning. Good morning.
And then the wonderful Jeff Hammond, who is going to be hosting our webinar. Hello, Jeff. How are you?
Good morning, everyone from the East Coast. How are things on the West?
Things are great. We actually had a pretty amazing week, right, Judy?
Yeah. We are approaching 10,000 attendees on our technical webinars. I don't think I shared that with you, Jeff. And we have a slew of new businesses coming on board: Dart, JE Pistons, Wiseco, Diamond, Manley, Competition Suspension, Pit Logic, Jacks. It just goes on and on. So it's been a big week.
Yeah, absolutely.
Congratulations.
Remember, Jeff, we asked you a couple of weeks ago, says, do you know how many webinars we produced? And we started to count. And so this is episode 97. And when we started back in June last year, what we did is started to count how many people we have registered per episode. And we're getting close to 10,000. So that's a pretty damn good number, isn't it?
It really is. And again, it's a big tribute to the fact of the platform itself. When you created it, you did it right. And I think you listened to a lot of your customers and people that have bought into what you have created here. And now it's gotten better and better and better. It's a lot like with these webinars we've been doing. We started out with the idea of an industry show for a week. And from that right there, all of a sudden we jumped on a rocket ship that went straight from the Earth to the moon overnight. And, we've been shooting at the moon, I guess, ever since then. They've been fun to do. They've been very informative. If you've been listening and following us, or if you're for the first time joining us, welcome. But more importantly is, I think earlier, and I want to touch on this, I think we got a second, is I want to say good morning to Ricky and those who are already in there. Ricky's from Alaska. I know he's already watching his own. Glad to have him. So all of you that are anticipating and participating each and every week or on a regular time schedule on Wednesday, man, we really appreciate you coming on board.
Thank you, Jeff. Thank you. So I'm getting a signal from our producer, Reed Keneski, that we're going to be bringing on our guest today. And I see John popping up, and I think
I'm going to unmute myself. Let me get my audio
and
going.
there you are. Excellent. Good
There
morning,
we go.
John. And we should be getting Kenneth. I see his name popping up.
Good morning, John.
Good morning. Good morning.
Okay, excellent.
Nice to see you, Jeff.
Good morning, sir. How are you doing?
I'm well, thank you.
There we are. Excellent. So, Jeff, you are in charge. We'll see you guys in the next hour. Thank you very much.
Yeah, sounds great. Sounds great. Thank you very much, Francis and Judy. John, good morning. Like we said earlier, hope you're doing well today, and glad to have you as being a part of this webinar today on EPARTRADE. And again, the great company that you're the president of. Very excited about that, I'm sure.
Yes.
But let me ask you real quick. I mean, pretty boisterous and in your face to call it the damn best. Okay. I have no problem because you can back it up, but I think a lot of people might say, well, how did you do that? Why did you do that?
Well, next month, this company will be 52 years old, which makes me also next month, I'm going to be 70. So I've gone through a lot of human things as well. When I started the company, I was 1 month out of high school in the town which I live, Poughkeepsie, and it was a local automotive machine shop. And as any 18-year-old boy would have been in 1969, especially when I was doing good work and progressive in the area, I thought I was the best. So in the beginning, answering the phone was I did answer the phone because the company originally started out as Dutch's Automotive Machine. And I did say Dutch's Automotive Machine when I got on the phone, but that wore out very quickly. So I abbreviated that to DAM. Then probably about in my early 20s, and I was looking for a logo because decals were just beginning to be important then. One of my mentors, Danny Jessel, before he was Jessel Company, Danny had a company called CMS. And I used to ride down there every weekend to see Danny and pick up small parts. And decals and logoing, what they call now, these marketing and branding, that was really just beginning in the early 70s. And so in attempts to have a branding for my name, I took the DAM, which people are now used to me saying on the phone. I put across the top and across the bottom best. And I felt, I genuinely, my world is very small. And things change over time. I laugh about it now. So as Danny progressed off and got Jessel and moved from calling it Competition Machine Service to using his last name, as my company began to be less local, and this is still going back to the 70s.
Right.
And we came to selling products across the United States. I hired a firm and asked them, should I use my last name? Should I go Satterfield? And this company, if I duck a little bit, move to the side, it wasn't cheap. This is, early 70s. Figures what $35,000 was worth in the early 70s. They gave it this brand, and they said, John, you've been using it for this many years. People recognize it. So we're going to mature the logo. And, has it been a good decision since? It's been very hard to live up to. There's been times when I've been humbled by it. There's been people that had personal criticisms of it. But now, after 52 years, the one thing I can tell you every day, Jeff, without hesitation, anybody that knows me, I try my very best every day, truly and genuinely. So living up to that original child appearance of things it's been a monumental effort. And I'm happy now to say that, I'm maybe not be the best, but I certainly do put my best effort in it.
Well, I mean, if somebody gets really hard on you, I tell you what I would suggest. and that was what you just told me. You could take the V off and put my damn best.
Yeah.
Because that's as good as you can get in my book. I mean, you're giving me your best every time you get ready to do a product, or we're going to talk about, what my needs are. If you're giving me your best, then it's not bragging, folks. It's a fact. And that, I think that's where I want to really jump off on right now and start saying, as you were evolving, can you give us some idea what you found to be the most important and critical thing that you learned at a very early age in your business that has basically stuck with your business and stuck with you for these 52 years?
I'll divide business over time, but I'm going to address business separately than performance. Okay. As a business person, and Kenneth called me a little bit before, but I genuinely believe this. My businesses always seek the skill of the least skilled employee. And I've had to really be conscious of that through its growth. So, we've had to make business decisions along the way because we're working with highly skilled, highly professional clients. So I've had to take and change the process. And Jeff, I took a few moments, actually more than a moment. I took an hour and a bit yesterday to watch the seminar to know who you were. Or I have not met you personally. We may have passed, but you did in social media. So I looked at that. Now I've got 1 month under 52 years of business. I have been through some stuff. And one of the things that I can't, and I have tried to do, is make my business be, and I use the thing, the McDonald's business plan, where you try to make $1 on a lot of parts. Well, it's impossible for this kind of business. When I'm working with professionals at the highest levels, like when I was doing NASCAR, and I would be at a lot of the races, and at the time I was leasing carburetors to 80% of the NASCAR teams. And after my injuries, that's when I started to manufacture carburetors themselves. So that has only been going on since maybe 2002, where I'm actually a manufacturer. Well, I realized, and I've tried to manipulate those pieces of the puzzle to try to get more customer base, larger number. I find as I've increased my number, by the nature of that, I've decreased the quality of my service. So business today is a balance, an important balance, to make sure I have the proper amount of time for the customer. That's probably more important than the part itself. I spend a lot of times, I always keep my notebook around, even during this conversation. I'm a very good note taker. I'll interrupt the customer to tell them I am taking notes, and only to ask them to explain it. And I have lots of notebooks. Like right around me right now, I have 3 computers. So that is a very important thing. So when you're dealing with NASCAR engine builders and tuners or professional drag racers, they may not be scientists, and most of them are not. So be able to explain to them at their level what they need to see that's important. And I used to be a part of the AETC that Superflow used to put on, presented there. And I have some, CDs and DVDs on some pretty involved subjects. So I've been training and studying all these years. We focused on fuel systems because, even though I've developed many other areas, after my injuries, it was the only one that was left that I could do. I was, at that point, a world-class triathlete too. I was on a bicycle training run. A car crossed the highway and hit me head on. So it really busted me up. And during that, recovery time is when I was designing the main houses and things and moving towards that, because I went from a carburetor modifier to a carburetor manufacturer,
Okay.
which is different. So, so at that point, I decided I was going to take all the things I had learned from carburetors in the past. And the other thing is that people have to make a conscious choice. When you're modifying somebody else's product, how much time are you willing to spend to explain to a customer that your modifications are better than someone else's? So I would go to the PRI shows and stuff. And, over the years, I realized that takes, even if I really genuinely feel that I'm doing a good job, I have testing facilities here, I'm at the racetrack with the highest levels, I'm communicating. The amount of time it took to make the sale eventually made it not worth making the sale. You're talking business now, so that's a conscious decision. I don't do things by mistake. I make mistakes, but I don't do them by mistake. There's a difference. So I make a conscious decision. Yeah, I can be wrong. My conscious decision was it would take less energy if my product performed better. We even made them red initially so people could see them, because you're selling a Holley carburetor. Everybody's selling a Holley carburetor. It's hard to see the difference. We made them red. Some people like it. Now we have multiple colors, and there is no current technology that we're using in the dAMBEST carburetor that's similar to others. We have a repositioned venturi, which means our venturi is above the booster. Have a patent on that. We have shear technology, which is inside the metering block, which is what we used in NASCAR. So you're shearing fuel at the rate of consumption, which is a pretty amazing thing. So you'll be able to shear the fuel, which exposes the hydrocarbons at the rate of consumption. So in our first test in NASCAR, when you're looking for fuel economy, it's really exposing the hydrocarbons. And we work with some of the people that you may know. Terry Elledge was with the Bill Davis team. We were at Indianapolis for a couple of weekends. And I know a lot of people that you definitely know. And the things that was really interesting, NASCAR can't run data acquisition during the race, but they can during testing. One of the most amazing, at that time, Dave Blaney and Ward Burton were the drivers. And 2 different drivers you couldn't ask for. So great example of things to learn. And we're at Indianapolis during that 2-week alternate test. And by watching the time live, I realized that when Ward would close the throttle, Dave was a lot smoother. When Ward would close the throttle, that the fuel consumption went up, not down. That was breathtaking, because they had real-time fuel turbines, so they were watching in real time the fuel consumption. And back then, this is going back a bit, you used to see these huge flames shoot out the exhaust, because once the raw fuel hit the exhaust, it would light, and these 6-foot, 8-foot flames would come flying out. And like most people at the time, not having that level of that acquisition to be informed with, I didn't realize it was because of closed fuel consumption. The idle circuit wasn't made for those high differentials. So, there we learned about closed fuel savings. So all of these went into the carburetor manufacturing. So as I developed the carburetor manufacturing during my injuries, I wanted the carburetor to sell itself. So I worked really hard for it to sell itself. The unfortunate part about that is the technology was beginning to strip my customer base. Even though they were professionals, they were not used to seeing the air fuel ratios, the VFCs that we're capable of running. So I had to teach them. Which was one of the things I was going to bring up about the fuel. Most people put the fuel in the tank and they don't understand the fuel they run. So part of what I needed to do with the professional is to explain to them the difference between, and we've had to do this for a consultant for other companies, between octane and distillation.
Okay.
Most everybody is aware of the term octane, but almost the same amount of people are completely, I don't like to use the word ignorant, but just not unaware of distillation and relative to fuel. All right. So I think that they can allow me to bring something on the screen. I don't remember exactly. I'll screen share.
If you can do that, go ahead and give it a try. We won't hold it against you. Like I say,
all right.
If we ain't trying, then
can you see this?
Can
you see it?
I don't see it. No, sir.
No. Okay. Let me back up a screen here again. Try again. All right. Oh, let me make this smaller. I got to figure out how to share it now. Here we go. Share. Can you see it now?
Gotcha, boss. I can't see it.
All right, but I have to get used to this. I don't do this often either. Well, this is when I give my seminars here at work. This is where we start. Even though we're about fuel delivery devices. That's what we're really talking about. Understanding the fuel is very important. When I was an outside consultant for Texaco Research Center, which is in Glenham, New York, which is about 15 minutes from me south, I was there for 15 years and I had my business here as well. One of the things I had them do at that time, the racing fuel we had here was CAM 2. If you remember, not CAM 2, I'm sorry, Union 76. Union 76 was the fuel that NASCAR. All right, well, that would be the horizontal line that's there. And the diagonal line that you're seeing on the screen is a conventional unleaded fuel that was at the same time. So I like to explain to people, if we take a temperature, the temperature would be on the screen to the right where it says temperature. And if we were at 270 degrees intake temperature and intake charge temperature, the high octane fuel would no longer exist. So that's what led to detonation and things when, or they had used to have in our days vapor lock, when the fuel would be completely vaporized and it would no longer be a gasoline, it would be just a vapor. So coming back from the end point is where the performance of the fuel comes. So you can actually have a lower octane fuel, and this is how they extend it today, give it octane, is by extending the end point, adding heavier ends to the fuel. So by changing the rate it distills, a lower octane fuel can still have what we call octane value. It's not the end point. It still has a distance to its final burn. So that's what we teach first, is even though you may have a high octane fuel, if it distills early over a short, like 20 degrees, in this case, you're over 20 degrees, you're distilling 80% of the fuel. Temperature is important there. And now today, NASCAR is running much higher temperatures. And if you look at fuel, which I don't have in front of me, I am just sure the fuel has a much later endpoint. So understanding the fuel becomes a very big part of designing a fuel system. We have different fuels. Let me just see if I can stop the share now. Here we go.
All right. Good job. Good job.
Okay, so that's what the chart is about. And we do it here regularly. Every time a customer calls, one of the things I do in my customer notes, not this notebook, is I want to know what fuel he's running, because the carburetor also is designed around the fuel. Its specific gravity, its vaporization rate, also what they call the vapor point. So we're actually designing the carburetor to fit the very fuel, not only the circumstances, but the fuel that they're going to run. So I'll take a breath there, because I can definitely run on for a bit.
No, that's good. I mean, that's good, because again, we got Chris already asked, he said, when you buy endpoint, do you mean the temperatures at which the fuel completes the distillation process?
Well, the endpoint technically is at 90%. The last 10% is when it turns to a residue. So when you're looking at a distillation sheet, usually not endpoint is considered the 90% distilled. And usually you'll see it just tag up at the end, and usually that's the real heavy ends of the fuel. So when they add ethanols or heavy ends, you know, when you look at the tar in the pan, that would be the tar. So when you're looking at fuels, and this is when we change the technology, we're forced to change technology in our carburetors and move more towards shear. And actually this happened in NASCAR and Busch carburetors as well, because when they went away from the union and started going to other fuels, especially when they went into unleaded fuels, stripping the hydrocarbons became very important for, you know, these burns are very fast. So if they have a high, fast burn, controllable burn, you need to strip the hydrocarbons away. So we moved into shear technology, both in the metering block, you know, when you have to run what we call a modified other, you're running a Holly carburetor or something else, we go inside the metering block and we have shearing going on. So as the rate of consumption, as it goes up the main well, it's the fuel is being sheared. You're putting air in to separate the droplets, but you're shearing the fuel.
Okay, let me stop you right here then. So make sure I understand here. If I'm a competitor out there and I'm listening to John Satterfield here, understanding my fuel is the beginning of understanding what I need to do with a carburetor.
Correct.
So you need to make sure you're not just going out and going to any hot rod place and just grabbing any kind of fuel. You need to be understanding, I'm assuming, specific gravity and whatever octane rate and how that goes with your temperature curve and all that, how that all that matches up. I mean, it goes right back to mathematics. You're going to have to do a little bit of math to understand where you are.
Well, at least look at the temperatures. Let me just give you, for instance, because a lot of it has to do with people say things regularly. They say, for instance, we dynoed one way, but it didn't race well. Well, when you're on a dyno, we'll just take a circle track engine, because a lot of people are familiar with that. You may be running on a dyno, unless you've got an endurance test. Today, they now have endurance tests, but a typical dyno run may last 6 or 7 seconds. I mean, it's not a long time, and you don't really get closed throttle testing. So something like a fairly flat distillation curve may give you the greatest dyno number. And because within the temperature that you're using, because as the air is coming in, it's also a heat of vaporization, it's cooling your intake tract. So you're actually lowering the temperature in the intake tract based on the heat vaporization of the fuel. So it'll tolerate that fuel. You go into the racing circumstances where the engine temperature is elevated. Now you're heat soaking everything. If you're in a circle track, you go to starting, flag track, you close the throttle and you're going to turn. Well, now all the exhaust during overlap is going up and superheating the manifold. So when you step back into the thing, your elevated intake charge temperature is going to be far beyond that fuel. So when they step in and they say it's lean and it's hesitation, well, that's just because the fuel literally disappeared. It's past endpoint. It may not exist in the engine at that point because of the elevated engine temperatures. See, drag racing does not have that issue. Drag racing is wide open, so you're not having the exhaust come up, during the race, superheating the intake charge, so that you're distilling the fuel with the engine's temperature. So knowing your environment. So a customer, and this is where it becomes important, customers say, well, I want to dyno on this fuel, but you have to make sure you let them know by the temperatures of your fuel, when you go to the racetrack, another fuel may be necessary. So you have to begin to educate your customer, because they always ask why. My favorite question is why. Well, the more you learn and you've been there, the more you can advise them correctly. And the same thing when you're changing the styles of fuel. Because then you'll say, well, a customer's complaining, my engine's running a little warmer. Well, if he's going to go to an E85 fuel, that fuel appreciates, because it's long distillation, a little higher elevated temperature. The same thing that happens with your street vehicles. When they add E85, the reason why that increases the octane is it stretches out the distillation. It's longer to the end point. So knowing this and being able to advise your customer is very important. And I moved away from using the term carburetor all the time to fuel delivery device.
Okay.
And the reason being, and I have it really close here, more than 12 years ago, maybe close to 15 years ago, I could get the date line, we came up with a replacement for the float bowl. This is an electronic jet. So we dealt with Scooter Brothers fast when it first got there. And this is back before as I was watching a seminar the other day where people had throttle bodies and boost. This way before that, we had electronic jets for carburetors. So I want to separate when you're having the electronic control and your fuel delivery device. Because today, and I have designed these fuel systems, you can have a multi-fuel device that can shear these droplets smaller than you can use them. And how do we know? Because we can create incipient detonation based on that temperature. Remember, the temperature in the elevator when you're driving around, your transient driving, as you're driving around, your intake charge temperature is going up. So your transient driving can lead you into hesitation. That's how you feel it in the car. The car doesn't go forward. You feel it as hesitation. All right. Well, that's actually the fact that your droplets have gotten so small. So controlling droplet size and temperature is a huge part of the fuel delivery system today. So transients, anybody talks to me, I'm really big on transients. There's not many circumstances where people are driving it wide open. So we want to make sure that the transients are good. So we look at all of those things, the application, and then we bring forth the fuel delivery device.
Okay. Now, Rich Tomei, he was wanting to understand a little better. Are we talking about how much the weather and outside temperature has an effect on it also? I mean, all goes into the equation, right?
Yes, it is. And this is the great thing about that. One of my favorite questions, as we've made the fuel droplets smaller, they become less weather sensitive.
Okay.
Because as they're going through the shearing process, the two things that we learned from that process, and this is when you have the difference between aeration and emulsion. I'm going to explain that because this becomes right to the point. When we first did our shearing in the metering block, we also have a gas turbine patent for jet engines. And we had to give a seminar to the jet industry. So I made visualizations of the difference between shearing and standard emulsion. So I did a clear tube, both the same, both had them, and this is, you have to understand, this is me now. I took a fish tank because I'm moving liquid. I put the vacuum source on a sealed fish tank. I put the two examples of the main wells, one with shearing and one with standard emulsion in the side. And I had these go off into the fuel source, which we were using odorless mineral spirits at the time, same thing I use today. And we put the vacuum source on the fish tank. So when you're showing it, if you show it individually, they'll always say, well, this was the difference. You put the vacuum source on the fish tank, so the vacuum on both wells would be the same. And so that when it drew through, you could see the shearing difference and the standard emulsion. Well, what happens is standard, we call standard emulsion, actually aerated the fuel. The air wanted to stay on one side of the main well, and the fuel wanted to stay on the same side where what jet was. It always wants to take the shortest path. So there really was very little mixing in the standard main well. Mm-hmm. But when I went over to because it was drawing at the same time, it would actually go through and look like a string of pearls when it went through the fuel delivery from the shearing, and then you have air coming in. So once it shears, the air coming in will allow the droplet to separate. So it wasn't just making small droplets. It was making sure they were evenly separated. So we're working on two items at once: shearing the fuel, mm-hmm. and then allowing air to keep it evenly spaced. So we went from aeration to true emulsion. Now in our good carbureted, we'll say a VP racing fuel with fairly flat, we run BSFCs in the low 30s, like 32. That's where we've decided to level off right now. So as we've made certain breakthroughs, we've had to stop and let the engine builder and technology catch up to us. Same thing is like when we're pro stock and we're tuning pro stock car teams, and we've done a lot of those over the years. When we get to 13.5, we make a little line. We say, okay, now we have to go to the engine assembler, the engine builder, and we have to look at under crown color. and see where they are in underground piston color and cooling to make sure that we can go beyond. Because I believe there's, at this point, there's no limited lean amp burn. If you're trying to make more cylinder pressure, a quicker burn, you have to go leaner. You have to over-oxygenate the hydrocarbon. That's why they use nitrous and other. More oxygen around the hydrocarbons. So the higher the piston speed, the quicker the burn, means you need to over-oxygenate the hydrocarbons. So that becomes, now looking at the engine build and heat rejection. So you're talking about a carburetor, but you have to have this back information in order to help the engine building. How are we going to make this quicker? Well, right during that, we look at underground color. And, and I say to some of the people, I'm not always a fan of these ultra thin rings, because you're looking at heat rejection from the piston. Even in a drag race, you have to make the other end of the track. Circle track, you have to finish the race. You have to get rid of the heat. So part of getting a higher level of tuning performance is now you have to look at the balance of temperatures. Well, guess what? That sheet again. The balance of temperatures. You can't get rid of the heat. You're bringing in this new intake charge. It's hitting the parts, rubbing around on the parts. Becomes more volatile. You can't bring a more powerful charge in the next one because the last one has just not gotten rid of the heat yet.
Okay, excuse me right here. You used the word bringing. I'm going to call a little timeout, and I'm going to bring in Mr. Kenneth Abbott from Abbott Heads.
Yep.
Glad to have you this morning. John's been carrying the load right now, talking about engines, and here's a guy that I think has a pretty good understanding of what it takes to get an engine together. And I would dare say you guys have probably spent many a time on the phone discussing fuel and how his fuel management system and how your heads and engines kind of all go hand in hand. Is that right, Mr. Abbott?
That is correct. Since I've got to know John and I originally got to him, I was running, working on some Top Sportsman stuff for my own program. I have a Top Sportsman S10, like showing in my background. My son drives it. We have a 565 conventional motor, 2 carburetors, 2 of John's Pro Stock Pilot or Dominators. And whenever I first started researching, we were having issues in low gear because the thing would pull 3 Gs on the start line. And my son could feel we were having issues, little stutters, and it was intermittent in low gear. And I started researching and found out John makes what he calls his Pro Stock metering blocks. And the jets are actually pulling out of the rear of the boat. I said, this is what we need, because I dealt with some other manufacturers and gone back and forth with them and talked to them about building me some metering blocks that way. And they all kind of poo-pooed it away. Once I got to dealing with John and my self-education of years of running carburetors, John has addressed all these issues that I was seeing in the Hollies and modified Hollies. He's corrected nearly all the issues that I found in his, even in the volume fuel. We used to run Texas Pro Stock, and we ran into it running Q16 at first and some C44 fuels, the really, well, they used to call rocket fuel in Pro Stock before they outlawed it, and C25. And we ran into regular Holly metering blocks would not supply enough fuel. The idle tubes in there would restrict the flow, and you could change jets and it never would change anything. So once I learned that, and I have other friends that's in the Pro Stock world that ran carburetors that I know and talked to them and their struggles of, feeding fuel to a Pro Stock motor. John could have really picked their program up. His boosters are 250 pins. They'll flow more fuel than, the size of the pins, and his metering blocks, everything will flow enough fuel to actually feed a motor making 1,400 horsepower. Our 565 makes 904 out of a 565. We've run 430s. We outrun a lot of 660, 700-inch motors that we race against with a little 565. But John is so smart, not only on fuel, but he also understands the engine part, the car part. He can help you in a lot of areas, and he's really stepped up my program since I've gotten to know him over the last 5 or 6 years. And yeah, and he can really educate you if you'll pay attention and listen. He's helped me a lot. Even in the cylinder head department, things that you get into, you know, I do a lot of stuff, drag race mostly, but also pull truck motors and things, and learned a lot of lessons to make a lot of power.
Well, that's why I say you two guys make a perfect pair then, because like I say, John was bringing me up to speed on the basic 101s about you got to start with good fuel and understanding the fuel and how it works within itself. Because that's the way, you know, that's the initial where you're going to find your power. If you can't understand how to get that fuel and control it and get the most out of it, you're leaving basically horsepower on the table and creating problems based off of what you're telling me. You know, you weren't able to get your fuel you needed when you needed it. And that created, you know, a stagger or a stutter or hiccup, whatever you want to call it, whatever the engine builder wants to determine. But the main thing is it costs you speed.
Yes, sir. The first time we put those carburetors on, my son, I didn't get to go to the race the very first time he bolted them on a motor. It was just a conventional headed 532 at the time. But he told me I need to give him a hug and a kiss. And I said, what? I said, who? He said, John.
I still got the text.
This thing picked up like 460 foot just right out of the box.
Well, the thing is
the other thing is, my son, we've had some carburetors in the past. He wanted me to tie on the back of the dually and drag them down the highway.
Yeah. Well, one comment I wanted to finish up on there when you was asking about weather sensitive. When we're doing all of this shearing stuff in the emulsion, you know, nice thing about having people race around the world and stuff, our carburetors are pretty much weather insensitive from 500 feet below at Virginia to a not very nice day at Denver. The most change that's been made for instance, a Pro Stock going from one track to another is a 2000s air bleed change on the high speed and a 2000s airspeed on the idle. That's a fairly weather insensitive car at the highest level.
Well, see, I'm glad you brought that up because that was one of the things I was kind of curious about. Is that, you know, you talk about weather and being around, you know, racing all my life. I mean, I know how sensitive, you know, read the plugs, you do this, you do that. You know, you're trying to get everything perfect, and a lot like, you know, and I'm going to use this, a motorcycle, for example. You know, you take a Harley Davidson and you start riding in the mountains with an old style carburetor, and you know, that some gun, it just wouldn't run right. You know, right. I mean, a fuel injector deal come up through there and just keep on getting, and you think that your carburetors or your fuel system would be just as sensitive maybe as that, but you're telling me that it's not. So, I mean, that to me has got to be music to my ears, because again, you're not going to be with me in California. You're not going to be with me in Denver, Colorado, but I don't have to do a lot of changing. I'm not guessing about what I need to do. It's what I guess is where I'm going with this idea.
Right. Well, let me get into the exact thing. The difference between a carbureted Harley and a fuel injected, we're back to the transients. Being that I do manufacture motorcycle carburetors as well, I wouldn't use a standard butterfly carburetor for a motorcycle because transients are very, 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 very bad in a butterfly boosted carb. What we do, for one, it's heavy in transients. One fellow you rent Ricky's from Alaska, we're going to be doing Lycoming aircraft engine carburetor and fuel systems. We're going to be changing them over from updraft butterfly boosted carbs to side draft slides. Because slides, now you're taking a carburetor and you can an electronic, we're just going to take a throttle controlled carburetor fuel delivery. If you look at a slide and you expose it, your fuel delivery at the point of the opening is going to be where the highest speed is. So if you go to our slide carburetor page, and you'll see the fuel distribution in the slide far exceeds a butterfly booster carb. So I wouldn't sell you that. I would sell you a slide carburetor that delivers the fuel at the best rate when it's opening because you're confining the area. A butterfly carb, you got the idle and transfer on one side and you got 0 on the other. So once you get to the point where I'm turning it the other way, you're getting enough fuel out of the main booster. You got the idle transfer on one side and the huge droplets falling from, depending on how it is, if it's downdraft or side draft. I'll explain in a second. So this is downdraft first. You get the huge droplets falling on this side and then puddling in the manifold. Motorcycle case or airplane case, you got a side draft with a butterfly. Now the fuel has the ability, guess what, to not go in the engine whatsoever, because the droplets are heavy enough and they're going to go by gravity. There's no law that says it has to go in the engine. You got an airplane with an updraft carburetor with a butterfly and a booster. The first thing I was telling the fellow Reggie is the fuel falls down. It doesn't even go in the airplane. The droplets are too big. How do I know? I watch it on my wet bench all the time. So when you're looking at the fuel daily, part of the recommendation of somebody who has a different application is making sure the fuel delivery device suits the application. I would not make a butterfly boosted carb for a Harley. I wouldn't do it.
Yeah. Yeah, it's good information, but I did see on your web page that you did do motorcycle carburetor. So I figured I'd get that in there on you, see what you thought. But another good question, I got a question for you is everybody, and Kenneth, please, give us your opinion on this too. I know that it may be challenging with the horsepower you're using, but how much better or how important is it to use, you got the engine dyno, a lot of people are getting the baseline on their product. Okay. But how important is it for them to take that information and go to a chassis dyno to do cross-referencing? Can you get good testing and results and stuff from a chassis dyno that will help you when you get to the track to kind of be ahead of the rest of the competition?
Well, I don't have any experience with a chassis dyno. I don't. I've
Too
never,
much power.
I know once I get to the racetrack, I know whenever I'd first built this engine I'm running, and we had dyed it up, looking at brake specifics and tuning it on the dyno. When I got to the racetrack, I had to go and totally change the tune-up major because, well, I had run it like the dyno tune-up in an 8-mile race and everything seemed to be fine. But I went to a 1/4-mile race. I think I had it Celine trying to make the numbers on the dyno look right, but it wouldn't run in high gear. So I had to put all that fuel I pulled out on the dyno back in it, and then it went to running. So, of course, you got a sealed up hood scoop, and we're running 190 miles an hour. So that changes, you don't have 190 mile an hour air running down that dyno scoop.
Mhm.
Changed it up major.
Well, Jeff, let me just comment on that.
Things. It changed the tune up a lot at the racetrack.
Dynos, because one of the things when I was working with Texaco, they had 200 dynos, chassis and others. So I have a little rule of thumb. The dyno in each of the cases you mentioned, first it was a engine dyno. I'm going to ask if it's a water brake, electric, or inertia. Each of those affect the engine differently. Typically, you're going to go to a chassis dyno. It's going to be inertia, and some will be water assisted. So when you're looking at how the brake functions against the engine, this is one of my favorite things. Think about taking a bicycle and pedaling uphill or pedaling downhill. Which is more difficult? Most people say pedaling uphill. Well, if you look at a water brake at high acceleration, it's relieving the resistance from the engine. So a water brake in dynoing is more like pedaling downhill. So the things you do to complement pedaling downhill won't be the same things you do to complement an engine pedaling uphill. So you have to learn, the dyno being a tool, is to how to take a water brake and get it to give you the information that, for instance, an inertia dyno will when you're driving the weight. If we go to the Grays, when they were running drag racing, they had an inertia dyno with a 2-speed Lenco, so that they were always driving the inertia dyno. And it would, measure the performance through the gear change. So I believe driving a weight is more like on-track performance than running away from the resistance. You can use water brakes, but you have to learn how they teach you. So you have to learn the range you have to do to get things, normally in a gear change, you have to learn to run below it and how to make it so it runs above it. But each dyno is a good tool, but it has to be interpreted correctly. So going from one style of dyno to another will show different results by the nature of it being running away from the resistance or running towards it.
Well, that makes sense when you explain it like you just did. It does make sense when you say it. Because again, depending on who you're talking to, everybody's got their opinion. But you have that's the best understanding I've ever heard, because I've worked with people who've had engine dynos that were, inertia drive dynos, electric dynos, everything like that. And you got to, like anything, you got to establish a baseline and know how to relate back to your baseline. So,
well, one of the things is with today's level of data acquisition, what I suggest all people to do is to turn their race vehicle into an inertia dyno and get the information from in-application usage. Right. So you have G meters that can calculate performance. You can go to the, take calculated G force through the gearing and calculate performance, because you can watch the gear, like even the first gear, you can watch the G meter go up and fall off when the horsepower falls off. So, and you can put fuel turbines in there. The only thing you can't easily put into a race car is an air turbine, but probably could do that today for test runs. But to convert your race vehicle into an inertia dyno is what I think most people should do today.
I want to deviate just a little bit because I feel like this is important, because my daddy always taught me you got to have two things to get an engine to run. You got to have fuel and you got to have spark. And then we're talking a lot today about fuel. What, in your guys' experiences and opinion, do you need to look for to make sure you're getting enough spark to adequately fire and take the full advantage of the fuel that you are working so hard to, put it in its best form to get the maximum power out of it? Do people sometimes have a tendency not to have heavy enough wire, good enough battery, alternator? Do you run into that sometimes?
Go ahead, Ken.
The ignitions nowadays are so good. Don't really see that too much.
Okay.
Main thing on the firing is going to be, as long as everything is mechanically okay and their wires aren't 100 years old or burning on the headers or whatever, that's really not an issue. If you get into the power adder guys, customers with nitrous and blowers and things, which are becoming so prevalent nowadays, then, if you got to pinch down the spark plug gaps and stuff, because so much fuel is so much in there, it can kind of snuff out a wide gap, but it's not normally a big issue.
Okay.
I'm going to mention
what's electronic stuff out there nowadays.
I'm going to mention the obvious. When we get to heavy fuels, for instance, and it may think this is not possible, but it is possible, diesel fuel, vegetable oils, nitromethanes, are really heavy fuels moving into plasma ignition, which when people talk about nitro and the sparks that those mags will generate, becomes necessary to puncture the fuel. So the heavier the fuel, you have to transition from a high energy spark to something that's truly more like lightning if you're getting into those heavy ended fuels. So once again, in the construction of fuel will dictate the spark. The lighter the fuel, the higher the energy single spark. I mean, we like multiple spark. We've talked about it for years. When Crane came out with this ignition where it was high energy, one spark, poof, we dyno tested that. That was an exceptionally good ignition system. I don't know if it's still made anymore, but the coil will dictate the ignition system. So when you're looking for ignition systems, make sure you're using a really high energy coil. And if you move into these heavier fuels, if somebody's dealing with heavier fuels, E85s or something, well, then going into a different system where you're going to go to possibly I go back to, because Crane made this, I think MSD does well, is going from high energy to plasma. So if you get a really cantankerous fuel that doesn't like to get lit, then switching from high energy to plasma.
Okay. Good information. Well, then let me ask you a question, because in my information about you, why would you say that a carburetor is a team player and not a standalone star?
Well, when I say it's a team player, because camshaft, thermodynamics, all have to do with performance of the engine. You can take, the highest level of carburetor, put it on an engine, but the rest of the team is not happy, the carburetor is not going to perform. So when I chose to go, not just because of my injuries, but to pick one of the things that I was very versed on, I'm versed on kinematics and fluid dynamics. So I have a lot of subjects I'm versed on. I said I want to use the rest of the information to support the fuel delivery, but it means that I have to have these high-level discussions on thermodynamics, engineering, and I get asked regularly about, rod ratios and things like that. What's my opinion on that? And cam events, for instance, when you're looking at the camshaft being as part of the team player, more overlap in an engine means when it idles, it's going to breathe more from the exhaust side, because the exhaust valve closes after TDC on the intake stroke. So long as the exhaust valve is open, then it's not likely to draw well on the intake. It isn't going to draw some, but the fact that the exhaust valve is open, there's no resistance there, means it's going to take some in from the exhaust. The carburetor, being a team player, means it has to add fuel to something it didn't supply. It didn't supply the air coming in the exhaust. It only supplies the air coming through its butterflies or its slide. But I'm a team player. The camshaft said that I'm going to have air coming up the header. Well, the carb says, okay, I'll take care of that. I'll give you a little bit more fuel. Fuel delivery device, and fuel injection or electronic, we can program that in there. We can add fuel during the idle, even though the air did not come down through the throttle body or carburetor device. So when you're looking at all of the system, the carburetor has to work within the system. Fuel, temperature, valve event timing, compression. There's a lot that goes into the system, and a carburetor doesn't stand alone. A good carburetor isn't going to make a great engine on a bad engine. It's just not going to do that.
Well, Ricky Craven is part of our group watching this today. He told me to ask John about the camshaft relationship. He changed when he changed his whole view of when looking for a cam on a particular application. You remember that?
Yes. Well, one of the things that I have, and I hold it up here, or see here, one of my Superflow conferences was the simultaneous evaluation of kinematics and fluid dynamics to increase power. That's a really good presentation to watch. I have moved away from thinking about camshaft center lines. I think about the valve events, open and closing, both the intake and exhaust. The center line of the lobe will be a default of having event timing. Most of the camshafts today are non-symmetrical, asymmetrical cams. How they measure the center line of cam is they go 50 thousandths before and 50 thousandths after. By the nature of that, my lobe looks like this. I'm going to have a calculated center line that it's actually not the center line of the lobe, the peak of the lobe. So how accurate is that? So if I go by event timing, all right, my intake opening, my exhaust opening, wherever the center line of the cam will be, is it falls. It's a default position. And I'm going to change the camshaft by half lobes and events so that I can optimize where it opens, or during overlap, like I'm going to trim, I use the word trim, the exhaust closing event so that I can draw harder from the intake side. One of the #1 mistakes in an engine, especially if they're dyno engines and not race engines, is the exhaust closing is too late. Because when your engine is at full steam on a dyno, then the scavenging effect from the exhaust works well across the chamber. But in transients, or when you're easing back into the throttle or gear change in the drag car, that exhaust valve being later and later costs performance because it's drawing the exhaust back in as the piston goes down before the valve closes. So when we move to event timing, all right, then we don't so much study the center line. It's a default of the events. That's what Ricky. So
all right, real quick, we've got about 5 minutes left here, guys. Chris wants to know, are there distillations curves of common fuel is something that he can get? Is there something you're willing to share?
I have them on all of my laptops right in front of me. I have 3. All fuel manufacturers post it. BP, Cam2, all of them. Go right on there. I keep it as a link. If I was going to grab the camera, I could easily bring it up now because I have to compare fuels around the world. If somebody comes up with a new fuel, the first thing I ask the customer to do is, or if he has a fuel he makes himself, is to send me the distillation for the fuel. Most fuels, one of the first questions I ask in every carburetor order is which fuel you're going to run, because that will change the idling and the air, the air fuel ratio I calculate carburetor on. Because the heavier the fuel, the later the burn, the bigger the droplet needs to be, because it's going to take longer to distill. So all manufacturers that I'm aware of post it.
Okay.
It's not a secret.
Well, I hope that right there will help him. Ken, real quick, you got some fans out there. Derek.
All right.
Derek has said, hey, Ken, you're looking good, man.
All right. Yeah, Derek's my buddy. He builds my valves.
Well, that's good. I'm glad.
They're Victory valves for a long time. They're good people and very good product. And I just want to add a footnote on that camshaft deal about going off event timing. Since I've got to meet John and I've evaluated the camshaft in my engine, just making changes based on that, what I've seen. Like I said, the lobe separation is wider than what most anybody would run, but we picked up 20-something horsepower and it shows it on the track. So it is valid. So, it's time I've been following his advice. We go faster.
Well, that's good to know. Because again, that's what part of these webinars are all about, is dotting the I's and crossing the T's. And everybody's got opinions and everybody, has got theories. And some of us, when I say some of us, when you're competitors and you've been in the business and everything like that, you've learned a lot of valuable lessons. Just like, like you were talking about, you had problems and you started looking for a source to get your problem fixed. And John Satterfield had what you needed.
Yes,
and it's like being a specialist and a doctor. You don't want to go to a dentist to get a broke leg or getting your heart worked on. So, you want to go to somebody who understands everything, the big picture. And it sounds to me, like I said, you two guys have gotten hooked up. And John, you're scratching Kenneth's back, and Kenneth, you're verifying and validating John's, information. So the main thing is you're creating a winning combination. And I just very impressed the knowledge that both of you seem to have.
Mm-hmm.
Well, thank you, sir.
So, John, you want to wrap us up with anything that maybe I've missed? I see Francis back on here with us. So you want to make
just to say, Jeff, that you've been a great interviewer. The nice thing about it is you're a perfect example. Hi, Judy. Hi, Princess. Of the people that I have to deal with on a daily basis. When I'm watching this, the nice thing about watching is I can see your expression and how you feel about the information and how I explain it. And this is what I have to do, because it's very difficult as you get to a higher level professional, which I certainly believe you are, being able to explain something without trying to make it a mystery. Sometimes somebody explains it purposely to make it a mystery. I need to be smarter. No, I need to bring the answer so it's understood. So, listening and watching you today during the interview was very enlightening, and I appreciate it.
Well, you talk in my language. I work off the KISS theory. Keep it simple, stupid, because I am stupid. I mean, I need it down to where I can put it in my little pea brain and rationalize it out. And a lot of this stuff that I saw and what I'm hearing is when I work with Junior Johnson, and we talk about carburetors and stuff like that right there. We had a big old wooden box right outside the dyno room. It was full of carburetors because he'd get a wild idea, said, well, I'm gonna drill a hole here and see what it does. And you know, that's the way they did it back in those days. And
Right,
you know,
right.
they only had certain things they could do. And here you come along and you say, okay, wait a minute, we're gonna fix something that could be very simple. You know,
Right.
I was looking at, I'm gonna digress here real quick. I'll get done, Francis. I've got a Model 8, belongs to my daddy. It's got an old Zenith one single barrel carburetor in it. And it's, you know, it's fuel and air mixture. But from that little creation right there to where you've got stuff today and all the horsepower and all the stuff that you can make is, to me, is mind blowing. It really is. It's been a pleasure. It really has, gentlemen.
Thank you, Jeff. Thank you very much.
Thank you, Jeff.
Thank you very much, both of you, for joining us today. I know Judy was excited to, you know, get you on board, John, and that was an important one. So, everyone, the webinar has been recorded, so it will be posted on the EPARTRADE platform within a couple hours, as well as on YouTube. We'll share it with you guys, and next week we will be back here at 9 o'clock Pacific. We're going to get the great people from Reed Rocker Arms, Judy, correct?
Yep, yep.
And so this is going to be another tech webinar on engine parts, and we're approaching number 100. So we'll have something special in the upcoming weeks. So stay with us. Again, thank you very much for
Thank you,
joining us
John.
today.
Thank you,
You're welcome,
Jen.
Judy. And any of the unanswered questions that want to be answered, they can just send them to me, either message or through the email for the business, and I'd gladly answer them.
Absolutely. And then we're going to push your products back to the homepage of EPARTRADE, John. So each and every one, go on EPARTRADE.com. You'll see a dAMBEST product right there. Click on it, and I will connect you as well directly to John and the team over there. Thank you very much, gentlemen. And we'll see you again soon, Jeff.
Thank you. Have a
All right.
great day.
Thank you. Y'all have a great one.
Thanks.
Thanks,
Bye.
Jeff. Bye-bye. Thanks,
Bye-bye.
Katie. Judy.